Press your remote to leave. What? Nothing happens? Try again. Let's get closer. Try again. Still nothing. Now I'm getting frustrated. Let me just walk up to this thing. There we go. Off we go. Let's fix this annoying issue. You're gonna need the key for your lock. You need the key for your motor, screwdriver to remove the lid, and a standalone receiver. Let's get the cover off. Put the gate on manual. Remove the theft bracket. Remove the 4 screws holding the cover in place. Now we've installed the third-party receiver. We've wired it onto the board. We've already programmed the remote to it. We're good to go. Let's close up the motor in the reverse order. Put the cover on. Close the manual release. Put the strap back on. Lock it up. Let's test it. And it's working. First time. Nice. But before we can do this, we need to know the basics of how the receiver works in order to wire the receiver onto the motor. Let's get into it. I will now take you through the basics on a relay PC board, a normally closed relay PC board, a one-shot timer PC board, and a remote triggered relay PC board. In front of us we have a 12 volt AC/DC switching 10 amps up to 280 volts AC. We also have a 24 volts AC/DC. It can switch up to 5 amps, 220 volts. We have a 220 volt AC relay, which can switch 8 amps up to 250 volts AC. Let's go through how these relay boards work. As the relay sits here, it is in a normally closed state. It means the common COM and the normally closed NC is currently in a closed circuit. And when you apply 12 volts AC or DC, the relay switches from normally closed to normally open, NO. When you remove the 12 volt AC DC, the relay switches back to common and normally closed. So the relay's resting state is normally closed, and when you apply power, it switches to normally open. The common or COM is your input. Because this is a 10 amp up to 220 volt AC DC switching relay, your input can be either 12 volts DC, negative or positive, or you can put up to 220 volts AC, neutral or live. A common use case for this relay would be to switch a AC device using DC current. You will connect positive and negative DC, and if you supply neutral into common and the DC circuit is turned on, it will use your neutral input and send it out of normally open to your circuit. For the next example, we have a 12 volt DC input. We are switching the positive on our DC side by turning the positive on and off, and then you will notice we have a bridging wire from negative bridged into common, which makes our input negative and our trigger is positive. And in this instance, we want to change the positive input to a negative output. So by using the positive trigger input and bridging the negative to common, when we apply power on the positive, the circuit switches from normally closed to normally open, sending negative current out of the normally open. So in our example, we have a LED light which is 12 volt, and we have the negative into our normally open, and we have our positive wired into the positive trigger. So using this relay, we're switching a positive trigger into a negative output by bridging the negative into common. So when we apply power to the relay, the LED light switches on. If we remove power from the relay, LED switches off. So in the resting state, circuit is on normally closed, and when you apply power, switches to normally open. Switch the power off, switches back to normally closed, and the LED turns off. And that's the basics of a relay PC board. We will now go through how to use a normally closed relay. Let's go through the reason for using a normally closed relay. The devices that you connect onto the normally closed relay is mostly devices that does not work off a relay itself. On the one side is power. You will have to power the device with 12 volts AC or DC. Next to it you'll see a trigger input. This is a normally closed trigger input. On the other end you will see there is a relay common, a normally open and a normally closed. In our example today, we will be using a set of door contacts to turn on a LED light using our normally closed relay. I will now take you through the connections we made. You will note that we have incoming power, 12 volt AC or DC, negative and positive. We also have our door contact, which is directly wired into the trigger. Then we have a bridging wire from negative to common, which is our input. I will link the video above how to connect a relay. On the LED, we've got the positive line directly to positive, and we've got the negative line into normally open. Let's power the system on. Okay, you will note that when the circuit is opened, the relay switches and the light turns on, and when you close the circuit, the light turns off. This can be used to identify when your pedestrian gate or your sliding gate is open. It can also be done by the motor, but this way if they were to derail your gate, the light would still go on even though the motor would say the gate is still closed. Another application for this, you can replace the door contact with a beam, point-to-point beam or any type of alarm beam that is normally closed, and that can also turn on either a relay or a contactor or a timer that can switch your garden lights on, or that can switch a alarm trigger on the alarm system. And that was how to use a normally closed relay. Today we will go through how a one-shot timer PC board works. Let's go through why you would need this PC board. If you have two or more devices triggering or releasing the same device, the power sent through the common of one of the devices will go onto the relay of all the other devices, and those devices can hold the voltage and keep the relays open, preventing the circuit from switching. In our example, we will be using a device sending a normally open as well as a push button striking a Cisa rim lock. The one-shot timer will be set to 1 second, so it does not matter how long your pulse from your device or how long you hold your finger on the button is. This will prevent the Cisa rim lock's coil from burning out. I will now take you through our connections. Our trigger device will have a common and a normally open, which we will connect to the trigger of the one-shot timer. Our push button also has a common and a normally open, which will go into the trigger of the one-shot timer. If you add a third or a fourth device, the common and the normally open of those devices will also go into the trigger of the one-shot timer. On the power side, we have a 12 volt power supply powering the one-shot timer. Our Cisa lock is being powered by an AC power supply. We have the live going straight to the lock, the neutral goes to the relay input, and the output goes to the other pole of the Cisa lock. Let's go ahead and test our connections. As stated earlier, we've turned the pod all the way to 1 second, so it does not matter how long you hold your finger on the button or for how long the trigger device is triggering. It will only send a 1 second pulse to our Cisa lock. Doesn't matter how long you hold your finger, only sends a 1 second pulse. And that was how to use a one-shot timer for multiple devices triggering a singular output device. We will now go through how a remote relay, or a receiver as we know it, works. We will be using a remote relay or receiver in the event that we cannot run a cable from the triggering device all the way to the receiving or pulsing device. You would then use a remote to trigger your remote relay device, to strike your lock, or to trigger your motor to open. In our first example, we will be using our remote relay to switch a DC device. In our second example, we will be using our remote relay to switch a AC device. Let's go through our connections. On our remote relay, we have a 12 volt power supply incoming. On our 12 volt LED, we have the positive directly into positive permanent. We have a negative bridging wire that goes into common input, and we have a normally open wire negative output to the 12 volt light. Let's go through our example. First, we will go through how to program a remote onto our remote relay. When you purchase your remote relay or receiver, you will find that there is 3 jumpers already attached to the receiver. Leave these on and power your receiver on to clear the receiver in case there is remotes that's been tested that's left on the receiver. Once you have a solid tone, remove power and remove these jumpers. So while holding your red button, you will just bridge the P2 pins. Remote has been programmed. In this instance, we want the light to stay on when we press the remote, and we want the light to turn off when we press the remote again. So we'll be using the latch function to use one of your jumpers you took off earlier and put it onto the L pins. On our wiring side, as we stated earlier, we've got power incoming. We've got positive to your LED, which is permanent to positive. We have a negative bridging wire to common, which is your input. And we have an output, normally open negative wire to our LED. When we press our remote, the light latches on. When we press our remote again, the light latches off. Our remote relay is being powered by 12 volt DC. Our lock is being powered by AC, where we have neutral going directly to the lock, and we have live going into our common input and from the output to the other pole of our Cisa lock. Let's go through our example. The receiver's pulse is 1 second by default. If you want to make it longer, you must use the delay function on the receiver. In our example, we only need a 1 second pulse to strike our Cisa lock. I have programmed a remote on the red button. Single second pulse. that was how a remote relay, commonly known as a receiver, works. We will now go through how to connect a ET single channel receiver onto a ET500 PC board. On the ET receiver, you will note that there is a negative, there is a positive, there is a common and a normally open. On the ET500 PC board, we will remove the 10 block connector so that you can see the labels at the bottom. On the receiver, you will see there is negative, positive. For power, common goes to CM on the PC board, normally open goes to PT on the PC board, which stands for button trigger. As you can see, we have negative wired into 12 volt negative, we have positive wired into 12 volt positive, we have common wired into CM, which is common, and we have normally open wired into PT for button trigger. And that was how to connect your receiver onto your ET500 PC board.